Hi folks, so welcome back. Today what we're going to be going over is another solids in contact question here, and what we're actually working from is page 61 of the DCG solutions workbook. It's solids in contact sheet 4, and what we're actually getting onto here, guys, is using Loci. Okay, so I'll run through a little bit on each question how it's going to help us. So question 1, guys, starting off, it says shown are the projections of a sphere. Point P is on the surface of the sphere. Complete the projections of a second sphere which is in contact with the horizontal plane and the point P. So first of all, guys, just a little bit of a recap. Okay, first of all, we're actually just going to locate point P in both our elevation and our plane. So what I'm going to do is, when it's a sphere, I'm going to take a horizontal cutting plane, and generally the horizontal cutting plane will go like that, but we don't need to do that now. Where it hits there, I'm just going to simply transfer it down to my plan view, and then when we do a horizontal cut on a sphere, we know that the image produced by it is another circle, okay, in our plan. I'm going to rotate that around, and somewhere along that arc there should be the point of contact right there. Okay, that is our point P in our plan view. Mark that in a little bit better there, POC technically, and I'll write POC up here as well. So at this point now, what they're asking us to do, alright, and this is the part of the question that can get a little bit tricky, is we want to complete the projections of a second sphere. They haven't given us radius, which is in contact with the horizontal plane and a point P, and the point P, or the point of contact. So we want to complete the projections of another sphere that is in contact with the horizontal plane. So therefore what that means is that second sphere is sitting on the XY line. Okay, so it's in contact with the horizontal plane and it's sitting on the XY line here. Okay, and it's also in point of contact, touching at the point of contact. Now we do not know the radius, so what we're going to have to do is we're going to have to use this thing called Loci. Okay, first of all, what we do know is when we have a sphere touching another sphere, and the points of contact, if we were to do it on the extreme kind of elements of it, okay, the extreme outside, okay, here at the right hand side of it, we know that the point of contact, when we rotate it around, the fake position of a point of contact for our go sphere, or go circle, will be out along here. Okay, so somewhere out along there, okay, we're going to have a sphere that is both touching the XY line and this, okay, and the larger sphere. So what we want to do is we have to set a path of points that are equidistant from both the large sphere and the XY line. Okay, so there's a couple of ways you could actually do this. Alright, so what I'll actually do, there's two ways you could do it. The way I learned when I was in school was I would go to the center of my from the center of my big sphere, and I would do a line out, and what I'm going to do is I'm going to mark out distances of 5 millimeters. Okay, 5 millimeters like that. So I'm going to mark out 5, 10, 15, 20, 25. Okay, and now what I'm going to do is from the XY line, I'm also going to mark up distances of 5s as well, so up to 25 as well. So I'm going to go 5, I'll do it, yeah, that's only so they can do it at 10, 15, 20, 25. Okay, so essentially I'm actually taking the same distances out from each one. I'm marking 5 millimeters up from the XY line, and I'm marking 5 millimeters out from the radius of the large sphere. 5, 10, 15, 20. Okay, so just watch this here. If I was to mark the first 5 and I was to make a line like that, and I was to go to the center of my large sphere and go to the first 5 millimeter out, you can see that little point there. Just make them a little bit more clear so you can see them a bit better. Okay, accuracy here is very important. And I'd take that distance and I would mark it down here. Now what I've actually found there is where the two lines have crossed, I have found the locus, or the path of a point. Okay, that is equidistant, it's equal distance from the XY line, and it's equal distance from the radius of the sphere. Okay, so now I'm going to find the path of the second one. So I come out to the second one, I'll mark it here, something like that, and then I'll go up to the second height. So that was 5, the next one was up 10, There we go. That would be the path of our second point. Okay, right in there. And as you can see, I probably didn't need 5. Okay, so I go on to the next one. I go on to the third one here. So this is the third one. And then third one up. And I'll do one more. Didn't need 5. 4 would have done. And then the fourth one up. Okay, and mark that in, and at this point what we have is we have a series of points here, okay, and this is the path of a point, okay, or a line, okay, so it's called the loci when a point is equidistant away from two objects, okay, so in this case it's away from the XY line 5 millimeters and it's away 5 millimeters from our large sphere. At this point up here it's 10 millimeters away and 10 millimeters away, 15, 15, 20 and 20. And what you actually do then is you connect up as best you can, you sketch the locus of that point. So you can see there I'm sketching that in, and where that actually crosses, okay, where that crosses out here where we connected it out to our fake point of contact, we have now found the center of our ghost sphere right here in this position, okay. Now at this point I'll just sketch that in, okay, just to show you there, that distance there from there to there should be, depending on my accuracy, it's not too bad. There we go. That there is my ghost sphere, okay, and that is the radius. We have now found the radius of that sphere. So ghost sphere. Okay, and what I want to do is, now that I've found the ghost sphere, I want to rotate it down, or project it down, and rotate it until it's in its correct position. Remember, this is the ghost sphere when it was at the extreme right of it. I rotate it down there. I know the center has to be somewhere out here along the point of contact, out there somewhere. What I'm going to do now is rotate that until it's in the correct position. Okay, found that right there, and at this point now I can actually heavy in my ghost sphere. So just switch it up, switch colors, and that sphere is going to be same radius as this one up here. There we go, and pop that in there, and hopefully keep this neat and tidy. There we go, bit of hidden detail there. And what we want to do then is, we have found the height for that up here, so project it up, and then that center has to be where this center is here. So I've now found the new center right in here. So same concept, and draw that in. This time this will be fully dark. Okay. Now, depending on your accuracy, you can see I went slightly under the line there, but you don't actually have to draw in this ghost one here. The whole point was just getting the center here at this point, alright? Make sure you locate your points of contact, obviously in both views, and then this bit inside in here of the large sphere, that would actually be hidden detail because our smaller sphere is in front of it, okay? That is the locus, or the path of a point that is equidistant from two surfaces, okay? In this case it was the horizontal plane, okay, so the ground, and then the actual large sphere here as well, okay? Hope you found that helpful, guys. What we're going to move on to now is question 2 on this page over here, so I'm going to scan out to that there now, okay? Right, guys, so the next question on this page says question 2. We're going to be using Loci again on a certain part of this question, but it says question 2, shown is a pictorial view of a cone which is in contact with a sphere, so we see that here. The front elevation and plan of the cone are given, so we've got the front elevation here, it's done. The plan view is incomplete. Complete the projections of the sphere, show the point of contact between the cone and the sphere, okay? And then the second part says is locate a cylinder which touches the sphere and the cone. The cylinder rests on the horizontal plane and touches the base of the cone at point B, okay? So we're going to focus on this first part here. It says complete the projections of the sphere, show the point of contact between the cone and the sphere. So anytime we have to locate the position of this this sphere down here on our plan, what we need to do is we need to rotate it around until it's touching the extreme generator up here in our elevation first. Okay, so what we're going to do is, we know the height of it, we can transfer that across, because the height of the sphere is going to stay the same height. Okay, and then the angle between the extreme generator, okay, which is this here, and the XY line, okay, when we bisect that angle, that should give us the center of this sphere when it touches both the extreme generator and the XY line. Okay, so I'm just going to bisect that there now, so I'll label this as well, XY line, and we will bisect that. So bisect that angle there, just about held it in. Okay, project that back, make sure, there we go. And at this point in here, okay, this point right here, that the point there is the center of my go sphere when it's out on the outside. Okay, I'm not going to draw in the go circle this time. This time I'm just going to project it down. Locate it here in position, project it around. It's going to be in there somewhere, and we know that in our elevation view, position of the center of it is there. Project it down to bring that around just a touch further, and there we go. We have now found the position of the sphere in our plan view. Okay, draw that in, drag that in. So take the radius from up here, the exact same, just draw it in down here in plan. And what we should have, guys, just in our plan view, because the sphere is overlapping the cone, that there should be hidden detail, so it should be a hatched line. Okay, we found it in elevation, it was already given to us, but the next thing we actually have to do is we have to find the points of contact. Okay, and we know the way to find the points of contact when a cone, or when a sphere is touching a cone, is perpendicular from the center to the extreme generator should give you the points of contact. So what we're going to do is, just very simply, just going to move this sideways here, line it up, put a little bit further, and then perpendicular I'm going from the center, not the bisected angle. There we go. At that point right there, that's a perpendicular angle there, but at that point there, that's where the fake point of contact would have been when I had my go sphere. I'll actually write that in here. That's the center of ghost sphere. Okay, and once again I can project that down. That's it there, and then rotate it about. That mark there, rotate it about. There we go. Just want to make sure it's getting the right part. There we go. And once I have it rotated about, connect the center of my cone to the center of my sphere, and that will help me locate a point of contact right there, POC. Locate that in my elevation by moving it up and then projecting it across. It's all to do with horizontal cuts. So at this point here, that is our POC as well. Okay, so that's the first part of the question done there, guys. You can see you can do these questions obviously without using the ghost or without having to draw the ghost sphere in. Okay, it's all about finding the actual center of it. Okay, just going to put this in here and I should have hidden detail in there. Okay, that's my hidden detail there, and as I said, she just hidden detail down here. Now we're going to get on to the second part of the question, which is going to use Loci. Okay, so what we have to do is, it says locate a cylinder which touches the sphere and the cone. The cylinder rests on the horizontal plane and touches the base of the cone at point P. Okay, so first of all, let's locate point P in our plan view. We have it in our elevation, so project it down to our plan view, and it's on the cone, and we know the cone on the ground is sitting flat on the ground, so point P is right here. So there's point P in our plan view. Now, what we have to do is we have to draw a cone that is essentially, or sorry, a cylinder that is in contact with point P. So if it's in contact with point P, then kind of like this one, where the point of contact is, you join the two center to center and you find the point of contact, or in this case, join the center through the point of contact, and somewhere out along there is the other center, okay, the center of our cylinder. We need to find where that center of our cylinder is. And kind of like the last question, what we're going to do is we're going to take equal distances from both our sphere and our cone, okay? So what I usually do is, as I said, I mark out either from the center of this and then maybe the center of this down, and I take equal measurements out, okay? So I'm actually going to, this is how I do it. They might do it a little bit differently in the video, okay? Sometimes what people do is, and I'll actually just do it here, I might as well, is I'm going to do a line like that, and then I'm going to do, that's a red line, and then I'm going to do a black line like that, okay? And just to show you there, I'm going to take the radius of the cone, which is that distance there. I'm going to take that distance there, and I'm going to mark it out along the red line, okay? I'm going to take that distance there and mark it out along the red line. Just make sure I found my center there. Then I'm going to take the distance of the sphere, just there. Okay, I'm going to mark that out along the black line. And as you can see, the distances between the two of them are quite different. Obviously we have a much larger radius for the cone than we have for the sphere. Okay, so I'll just write a C there and then an S here, so you know which one it is. And what we're going to do is we're marking equal distances of 5 millimeters, okay, or 10s afterwards, but I like to do 5s when these measurements. If you have bigger drawings, you might use 10s, okay? So 5, 10, 15, 20, I think 4 might work, so we'll stick with 4. Same thing, 5, 10, 15, 20. So what I've done is I've marked it from the radius out, okay? That's why I was saying a minute ago, what I'm doing is essentially, just to show you here, if I was to go back to my old way now, and I'll just show you how they're similar, okay? Literally I'm just marking out 20 in measurements of 5, or increments of 5. So 5, 10, 15 and 20. So essentially those 5s that I've done, 5, 10, 15, 20, are the same distances as these ones here, okay, because that distance there, the radius of the cone, I've marked it out here. I just think it's easier to keep it on the actual drawing here rather than going off doing it somewhere separately, but whichever works best for you. Now you could also do it down here as well, so I'll do it from the side of it here. Okay, and I'm just marking it out because I know it's going in here, so I want to keep that neat and tidy. So same thing, 5, 10, 15, 20, okay? And at this point what we're going to do is we're just going to mark those, okay? So for every 5 that goes away from the cone, okay, it's going to move 5 away from the sphere as well. So let's get the first one. So if I was to mark that distance there, which is the first 5 millimeters out, it should be the same as this over here. And it is, okay? So mark that 5 millimeters out, and I assume it's going to be somewhere inside in here. And then I do the exact same with this guy here. Go to the first 5, and it's going to be back in here. Okay, and what we've actually found there is the locus of a point that is 5 millimeters away from our sphere and 5 millimeters away from our cone. Now we're going to find one that's 10 millimeters away from both. So here's the 10 one, and I'd imagine it's going to be somewhere in there. And the exact same with this guy. Take that distance. Yep. Okay, there's our second point. onto the third one, and then onto the third one down here. We might need 5 on this one. Fourth, and then the fourth one here. It's kind of coming out just outside it there, so we should be okay, but I am going to do a fifth one just to give it a little bit more clear. So I'm going to do one more. 5. And I think these will be a bit more accurate when you're using a sharp pencil. I'm using a pen here that's quite blunt at the top of it. There's the fifth one there. And I'll do the fifth one here as well. That distance there. And there we go. Okay. I think the fourth one was just a bit out. So, at this point then, what you would do is you would connect them up. Yeah, I think the fourth one is just a little bit out there based on my accuracy, but that's the path of a point. Okay, that is the path of a line that is always equidistant both. Like if I was to pick a point here, right in the path of that line, okay, if I was to pick that point there, that point would be equidistant away from the sphere, and it would be equidistant away from the cone. Okay, this point, anywhere along that line is the same distance away from the sphere, and it's the same distance away from the cone. Okay. But where it crosses, we know our centre is out along this line here, so where it crosses that line there, which is right here, we have now found the centre of our cylinder. So at that point there, then, what we can actually do is we can draw in our cylinder. We know a cylinder, when we look down top of it, is a circle. So if I'm accurate here now, our point of contact of a cylinder and a sphere should be where the two centres connect once again. So I'll join the centre to the centre, and depending on my accuracy, the method is right. Okay, our point of contact should be here. That's my other POC. That's actually a POC. Obviously a POC up here. Okay, so hopefully, depending on my accuracy, we'll see this distance from here to the point of contact should be the same distance from the center to the point of contact here. So the radius should be the same. We'll see how it's close. Yeah, it's not bad. Happy with that. There we go. And that is the plan view of my cylinder. So I want to project that up to my elevation view. We know when we look at an elevation view of a cylinder that it will be a rectangle. Okay, and they haven't told us the height of it here, so I'm just going to give it a random height. I'm going to bring it something like this. So I think that's what it is like in your DCG solutions book. And that's there. And at this point here, this will actually be a heavy line going down here. Okay, that's the elevation view. And then if I was to finish off, that would be heavy. And all of this in here is hidden detail. Okay, and also this little portion of the sphere and elevation there, that should be hidden detail as well, that bit there, because we can see the sphere is slightly behind the front of the cylinder. Now the last little bit there is just locating the final point of contact. We have this one, but we also have to find this one up here in our elevation view. So it's just in there. So what I would do is I would project that up. It's coming up inside here. And we know a sphere and a cylinder, it's kind of hard to see there now because the lines are getting quite close to each other, but we know a sphere and a cylinder will have their points of contact at the radius height of the sphere. So if we project over the centre of the sphere, right there, that point there is my point of contact. Okay, tricky enough question there, guys. That's getting really kind of into the more higher level aspect of the solids and contact stuff there. Hope you understood that. We're going to move on to question 3 now. Okay. Right, guys. Question 3 here. So on this solids and contact sheet 4 page, it says, given are the partial projections of two cones A and B which are in contact with each other, so A and B, and we've obviously only got cone A down here in plan. Complete the projections of the cones, so obviously we have to get the cone B down in its correct position in our plan view. And then the next part says an inverted cone, okay, so that's a cone that is basically where its tip is on the ground, so this bit here is actually on the ground and the base, okay, the circular part is facing up. An inverted cone is touching both of these cones. Draw the plan and elevation of the inverted cone when given its point of contact with cone A, which is at point P. Okay, so we're going to have a point of contact at point P. So first of all, before we get onto that bit, it's going to involve using Loci again. We have to find cone B down in our plan view. Okay, so to do that, first of all, what we need to do is, okay, this is actually easy enough one. We know the center of cone B is directly below its apex. So if I project down the apex, I know the center is somewhere down along there. Okay. The next thing is we know that the cones can only touch each other as well along their kind of circumferences, so they'll actually have to touch. They can't touch somewhere in here on the face of it. It has to be where they meet at the ground. The next thing I would notice is I can actually get my radius straight away from the elevation of cone B. Okay. So with that radius, guys, okay, that I said I can get from cone B, alright, with that radius, what we can actually do is we can take that distance on our compass, okay, and we can actually mark it out. So I'll take that distance on my compass, radius of cone B, I'll be accurate now here once again, take that distance, and what I'll actually do is I'm going to mark it out, okay, from the center here out, okay, or I could mark it from here up, okay. Just imagine I've moved it right to the side of it, so I'll actually mark it out there. So basically I've taken the radius of that cone B and I've moved it out from here, bottom over the extreme generators, okay, or I could have done it down here, would have been absolutely fine. And at that position there, I'm going to rotate it then, okay, because that's technically what I've done there. Is all I've done is I've basically moved cone B over until it's touching the extreme generator, but the center of it is here. Okay, if I was to redraw it in, I could just draw it in there just to give you the idea. Don't have to, but it would just give you the idea where that would come up there and this would go down here. Okay, I'll actually put it in green, and this is kind of our ghost cone, okay, and you'd get it there, but I've just drawn half of it, okay, but that center has come down. I'm going to rotate, bring it down, rotate it around, and get it in its correct position. Rotate it around. There we go. And I found the center of it, of cone B in its correct position. So now what I'm going to do is I'm going to connect it up to cone A. And at that point there, we have now found its point of contact right here. So that's POC. And I can actually draw in cone B in my plan view in its correct position. So same thing, take the radius again, trying to be as accurate as possible. Technically it should be where point of contact is, yeah, and that worked out fine. There we go. Okay, that's cone B in our plan view. I'll just put in B there, and what I'm going to do is I'm also going to project up the point of contact. Always let the examiner know where you get your points of contact from. So point of contact, and it has to be on the base. So point of contact is going to be right there in our elevation view. POC, right there, okay? So now the next part of this question says an inverted cone is touching both of these, okay, of these cones. Draw the plan and elevation of the inverted cone when given its point of contact with cone A, point P. Okay, so it's an inverted cone. So basically what we're going to have up here is, instead of the cone being up like this, it's going to be a cone like this. Okay, so that was a terrible sketch, but you get the idea. It's going to be upside down like that, okay? They have given us the point P, which is its point of contact, okay? So I'm going to assume that point P is actually where the top of the cone is, okay? Or in this case, the base when it's flipped up, and that's the height of it. So what I'm going to do is I want to find point P in my elevation view, okay? So what we're going to do is we're going to take a horizontal cut for point P. I'm going to take a horizontal cut. So what that involves, revolving P around cone A until it touches the extreme generator. So if you imagine there now, I'm actually going to put in the whole cut to give you the idea. So I've revolved P around, okay, until it hits the extreme generator. When it hits the extreme generator, project that up, and basically hits the extreme generator here. That there is what my cut looks like, but if I want to find the exact position of point P, I project point P up there, and I've now found P in my elevation, which I'm actually going to call POC, okay, because that's the point of contact. Now, if it touches cone A at this height, we would assume that it also, okay, has to touch cone B at this height as well. So I'm actually going to project that over as well. Stop there. There we go. It's at the same height, and at cone B then that will go down, and what you would actually have there, and bear with me now because my compass won't let me draw something that small, but what you would actually have, and I'm just going to sketch it, okay, but you get the idea. You don't have to sketch this, but that from there is essentially another cut, okay, and we'll cut the top of it off as well. Alright, compass just won't let me draw something that tiny now, in fairness, guys, okay. So what we have to do is now we have to do loci of a point, okay, of an inverted cone that is going to touch cone A on this kind of horizontal cut, okay, at the point P, and cone B at this height as well, okay. So we have the heights, they're out here and they're out here. So we do know the height of it, it has to be up this height, okay. What we also have as well is a point of contact from cone A. So if I connect cone A, the center of it, the apex, out through the point of contact there, somewhere out along there is going to be my center point. So at this point now, what we're going to do is we're going to take equal distances out from cone A and cone B, but we're not going to take them from the bases, we're going to take them from the horizontal cuts this time, okay. So I'm going to take distances out, and I'm going to do, the first one I'm going to do is 10, and then I'm going to do 5s after that. I'm going to do 5, 10, 15. So that's the first 4. So I skipped 10, okay. I could have done 5, 10, okay, but I just skipped the first one, and I'm going to do the exact same at this one here, okay. I'm going to bring it out, and I'm going to mark, actually, do you know what, I'll bring it down instead rather than out. Apologies for that. And I'm going to mark, as I said, I'm going to mark whatever distance. I'll actually bring it out, guys, instead, because I have a better accurate measurement there. So 10, and then from there I'm going to do 5, 5, and 5. Okay, so if you see it there, it's like 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, so the same thing here now. What we're going to do is we're going to rotate around with all of those until they match up with each other and get the locus of a line that's going to be equidistant from both. Okay, so at the first one, at the 10, it's going to be somewhere inside in here, and then the exact same with the next one. I'm going to do it from here to here. There's our line. Okay, that actually doesn't meet. Okay, so that doesn't meet the first one. Okay, the first 10 actually doesn't meet. So now we'll go on to the 15. So it's outside. I think this one's going to meet this time. Yeah, this one should meet. So I'm going to the next one, and we can see this one actually does meet. It's going to meet right there at that point. So I use different color. And now I'm on to the next one. I might need a couple more here, I'm guessing. You can do as many as you So now what we've got, guys, is the path of a point, okay, that is equidistant from both the cutting plane that we found on B and the cutting plane that we found on A. Okay, so I'm going to sketch the path of that point. Having sketched that now, we knew that the centre had to be out along from the centre of cone A through the point of contact, out along there. The centre had to be had to be out along there. So where the locus of our line, okay, at the locus of the path of a line, okay, that was equidistant from both cuts through that, we have found the centre, okay, of an inverted cone, okay, and it's going to be right there. So hopefully at this point now, the radius should be from that centre to P. So we'll see now, does that work? And it should overlap both cones, and it should probably touch inside in here as well, and that's looking pretty close. Yeah, I'm happy with that. So there we go, and it's just about fitting on my page. There we go. So we have an inverted cone, okay, that is actually the base of the cone, okay, because the apex is actually on the XY line in this case. And at that point there now, we have, if I was to connect up this to this, we would have a point of contact right here. I think it was there, yeah, it'd be around there, okay, and that would be another POC, okay. And what we want to do now is we want to project those up to our elevation. That's the overall width of it there. Find it here, there's the height of it. The centre is on the ground, so it's going to be right there. And at that point there, that is going to connect over to here. This is going to connect over to, I'll just find it, make sure I get the right point. Right there, yeah. And there we go. That is our cone in our elevation view. Okay, you can see the point of contact there. If I wanted to find the point of contact for this guy, he would be up here, be right there. Projected him up. That's our point of contact, POC as well. Okay, 3 objects, 3 points of contact in each view. 1, 2, 3, 1, 2, 3. Okay, a little bit in that question, probably a little bit more awkward. Accuracy might have been a little bit out down here, okay, but the principle was right, okay, and the method was right, and that's the main thing, okay. So try and get that done there, guys, and what we move on to now is question 4 on this page, okay. Right, guys, so the final question here, guys, question 4 on sheet 4 of solids in contact. It says, shown are the plan and elevation of an inverted cone, okay. A sphere is in contact with this cone and the vertical plane. Okay, it's a little bit tricky one here, I'm guessing. Given the point of contact between the cone and the sphere, complete the projections of the solid. Okay, so on this one, guys, what we're actually getting is, first of all, just before I even get on explaining, what we're going to do is we're going to locate the point of contact in our plan view. Alright, so horizontal cut across it, going to get the point out when it's on the extreme generator. Project it down, and hits the axis line. We're going to rotate that around, okay, so rotate that around until it's in the correct position. Alright, and once I rotate it around, the actual point of contact in this case is going to be here. I'm going to explain why. Any other question we've kind of done on these guys so far, the point of contact has generally been kind of out here at the front, but in this case it's actually, it's actually at the back. Okay, so this is our point of contact. Just going to write in there POC. Okay, and that would be POC in our elevation. Now, the reason for that is because if we read the question, it says, shown are the plan and elevation of an inverted cone. A sphere is in contact with this cone and the vertical plane. Now what we have to remember is, okay, the XY line, okay, is the intersecting line where the vertical plane meets the horizontal plane. Okay, in the plan view we see the horizontal plane, in the elevation view we see the vertical plane, and the XY line is where the two of them meet. So technically, if I was to cover over this, our plan view, okay, which we have here right now, when we just have the XY line, technically that is a wall that is like it's coming up out of the page. Okay, it's like it's coming straight up out of the page, going across like that, going down. That's our wall. Okay, obviously that wall we see it, when we see it in a bird's eye view, we see it as a line, whereas in the elevation we would see it, okay, as the plane, whereas our ground in the elevation we see it as a line. Okay, whereas in our plan view we see the ground obviously as a surface. So that's all it is. Okay, in the plan view we see it as a surface, the ground as a surface. In the elevation we see the ground as a line, vice versa. In the elevation we see the face obviously as a surface, whereas we see the ground as a line, and so on. Okay, hope that's not too confusing. It says then, okay, so basically we have an inverted cone that and we want to draw a sphere, okay, or put in a sphere that is located here at the point of contact, and it's also touching the vertical plane, so it's touching the XY line, which is the wall. Okay, so essentially it's going to be kind of up here, I'm imagining somewhere. It's going to be up around here. It's not actually touching the ground, so it's not on the ground, it's going to be on the wall. So this is actually kind of similar enough to other questions only that we have done in the very first one, where we measured up from the XY line in the very first question we did in this page. Only this time we're actually probably going to be measuring down. Okay, so what we're going to use is the principle of when we have the point of contact. What we've done is we've rotated around here in this position to our extreme generator, okay, and we know anytime we were to get a ghost sphere, okay, anytime we were to get a ghost sphere, what we would usually do is we would go perpendicular to the point of contact when it's on the extreme generator. Okay, so that's what I'm going to do first of all. So I'm going to line up there with my extreme generator, like that. Pull it back, and somewhere out along there, okay, the reason I use the extreme generator is because somewhere out along there would be a ghost sphere that we want. Okay, somewhere out along that perpendicular line from the extreme generator would be a ghost sphere of a radius that we want. Okay, I couldn't do it from the point of contact because that's not in the correct position to get in the perpendicular line, okay, from the extreme generator. So somewhere out along here will be a center of a ghost sphere that we want, and then we would rotate it around into the position. So what we're going to do is we're going to take distances out along that line there, okay, and whatever distances I mark out along here, I'm also going to mark those distances down from my XY line as well. Okay, and then the next thing as well is we know that a cone, okay, an inverted cone in this case, and the sphere, we know they're touching at the point of contact, so the center of the sphere that we want has to be somewhere out along that line there. Okay, so what we're going to use once again, guys, is Loci. Okay, so I'm going to take a distance down. I'm going to start off with about 20, then I'm going to do 5, 10, 15, 20, so about 5 distances there. Okay, might need all the way out to the 5. So if I've done 20, I'm going to also mark down 20 as well, okay, from the XY line down in this case. So I'm going to connect them up, and I'm going to mark down 20 as well. So just mark down. Okay, mark down 20, and just see it'll do for the very first point. Okay, so what I have to do here, guys, remember that extreme generator, I'll do the same here. So that extreme generator was here. I project this down, okay, and I would mark those distances out. Okay, so you can see there's the first one, there's the second one, there's the third one. Okay, and what I have to do now here in this position is I'm going to rotate the very first one, which was the 20. I'll rotate it up like that. And then also where that rotates up, I'm going to mark out 20 like that, that one, because that distance out, this distance out here was the same distance down here. So I've now found a point on my locus. Okay, I'm going to do the same here with the next one. I might actually come back in a distance as well. So instead of going out 20, I'm going to go out 15. I think I might have gone out too far. So about 15. There's a bit of playing around with Loci, guys, okay? So pull that down. And then obviously I'll do the 15 here as well. So mark 15 down. It's about there. Okay. And rotate the 15 around. Okay, that one actually doesn't meet. So the 15 doesn't meet, alright? So it was good to figure out. So now I'm just going to mark down the next 5 on this one. So mark down the 5. Okay, and I'm also going to mark out the 5, which I had done previously. And there's another path of a point right there. And I'll get one more. It's going to be in there somewhere. And it's going to be down another 5. I know I'm going in the wrong direction now, but it's just helping you get a clear idea of where the path is coming from. Because technically I should be going over that way. I can see that. So it'll be from there across. That's after giving me another point. Okay, so there's a point there. As you can see then, technically, I'll try and do this as best I can. That'll be going over there like that. That's the path point. Locus, okay, that's equidistant from the point of contact and the XY line, in this case the vertical plane. And I need one more, okay, so we did 15 and we did 15 down, and we also did 15 down here, and they didn't meet, okay, so in this case then I might go a distance in between them, and I'll mark out, I'm going to go another 3 millimeters. There's 3 millimeters both ways, that'll probably meet. So there's 3 there, okay, and then from the 15, so from the 15 it'll be 3 down more as well. So there. So hopefully this one will be the one that will work for us. So it's in there now. I know that's getting a little bit confusing, guys. I hope you can kind of follow that. And from there I've got to project that 15 down, or the extra 3 down I should say, and then rotate that around. Yeah, and that does meet it. Okay, so that's after giving me a point. So just to find it there, I went up here. So I think that's it there. Yep. Follow that around. Yep, that's it there. Okay, that worked perfect. Bit awkward there now, guys, that one. Okay. So you can see here it's gone a little bit messy inside here. You just have to be able to follow it, okay? What I've essentially done is from where my point of contact, my fake point of contact for what would be a GO sphere out here, okay, on my extreme generator, I measured out distances out here, okay? I started with 15, so 15 didn't work. So the first one actually that worked for me was 18, and then I did 20. Okay, so you could go 18, 20, or you could go 18 and then 5s after that, but I did 18, 20, 25, 30. Essentially is what worked for me. So I've marked down here 18, 20, 25, 30, and then from them, when I brought them down, I had to project them up, okay? So that's the confusing part, is when you bring them out along what would be where the center is joining up to the point of contact. You have to project them down and then rotate them up. So that's a little bit tricky there. But anyway, what I've got here, you can see here, I've sketched it in. I've got the locus of a point, or the path of a point, that's equidistant from where the point of contact is and the vertical plane. Okay, so now where that crosses over, remember our center was out along here, that point right there, okay, that point right there is our center. Okay, and you have to remember it touches the vertical plane, so the distance, my radius then, is from here, up to the XY line. So I'm going to pop that in there. I'm going to put in a straight line up to it. So there's a bit in this one now, guys, just understanding. That was a little bit tricky. So that distance there that I've just put in, okay, that distance from there to there is my radius. So at this point now, I'm going to pop in just my darker colour here. It is underneath it, so there'll be hidden detail here. So what I have is a sphere, and hopefully this works out. There we go. And inside in here, what you'd actually have is hidden detail. Trying to make that as neat as possible there, guys. Okay, so that's basically the idea there, guys. You can see it's pressed up against the back wall. Now that we have found in our elevation, okay, or sorry, in our plan, we need to find it in our elevation. Okay, so just applying the principles, I know where the center is. It's going to be up here. It's up there somewhere. Okay, and then what I need to do is I need to find the actual center, okay, when it is here, and I'll rotate it around. It's the exact same height of it, okay. So that center there was right here. Alright, it's right there, so I can actually find that. It's on the path already. So when I rotate it around back to the extreme generator, it would come down here, and it would have been right here. It's actually bang on the 18, okay. So that's the height of the center there, okay, as it rotates around. So technically, my new center, once I bring that one over, a little bit in that, so that was the height of the center, okay, when it was rotated around, and my ghost sphere, we found it over here, and what we want to do is we want to rotate it until it's in its correct position. So when that's rotated in its correct position, it's right here. Okay, take the exact same radius as I had in my plan. It's at the back, so there's going to be a bit of hidden detail here again. So this is all going to be hidden detail here, guys. And then this will be heavy. Now it might look like it's on the ground there, it might be, I don't know, it doesn't tell us that it's touching the horizontal plane, but what we do know is that it is definitely touching the vertical plane, okay. A little bit in that question there now, guys, that was a bit tricky, okay. If you can understand that, you're well on your way to understanding how to use Loci there, guys, okay. So try and get those done when you can. Well done.